My name is Noah, and this is my Physics 2 Lab 1, in which I determined the charge of two similarly charged pieces of tape using Coulomb's law and Newton's first law. And I was able to calculate that the charge on the pieces of tape is equal to 1.91 times 10 to the negative 8 coulombs, or 19.1 nanocoulombs, and we'll get into exactly how I calculated that. So as I mentioned before, I used Newton's first law, which states that an object will sort of maintain its inertia unless acted on by an outside force. And in this case, the application of that is to say that if an object is at rest and is remaining at rest, then the forces on it must cancel to zero. I also used Coulomb's law, which states, or which gives the relationship between how charged particles enact forces on each other. You can see that right here. And I was able to use these two models, and particularly Coulomb's law, which states how charged particles interact, to determine how the two charged pieces of tape would behave next to each other. Now, here's exactly how I lined up the two pieces of tape. I charged both of them in the same way, except for the one on the bottom was half as long, and I held the bottom tape up to the top tape until the top tape was floating, and then recorded the distance between them. And in this case, this top tape here would be the system, and everything else in the picture would be the surroundings. And the initial conditions, and I suppose the final conditions as well, would be this top tape being at rest and in this new equilibrium position where all the forces on it are canceling out. Now, as for the coding in this project was extremely simple. I just calculated the force of gravity that the tape would be experiencing, assuming that 1 gram of tape is 1 meter. So I made that assumption, and from that it followed what the mass of the tape was, and then did some math to figure out the charge that would be necessary to cancel that gravitational force. And that math is down here. I did assume that all pieces of tape had equal charge, and I also assumed that these pieces of tape would behave as a point charge. And this is what I end up getting from that, and the charge on the tape that I calculated was this 1.92 times 10 to the negative 8 coulombs. Now, one major possible source of error from this would be that the tape, as seen here, was kind of suspended on the ends, so my weight estimate is probably off, and there would be other forces that I'm not accounting for holding the tape up. However, this is still a fairly reasonable approximation. Now, as for the what if question, it asks, if protons and electrons had their charges flipped, what would change in the interactions between charged particles? And the answer is nothing at all would change, because the way that positive and negative charge is labeled is purely arbitrary. We have decided which one is positive and which one is negative, and the only salient part of that distinction is that they are opposites from each other. So if they were to be switched out, nothing would change at all. And as for the why we should avoid handling the tape except for on its very ends, it's because the tape is storing electrons on it, which makes it charged, makes it negatively charged. And by handling the tape, we might conduct some of those electrons away, therefore making it less charged and making the effects from this lab less pronounced. Thank you.